Hi everyone, this video is on exercise 11a question 5. So we are given this equation, which is the integral of e to the x plus e to the minus x is equal to 48 over 7. And we want to find the value of a. So we first need to integrate the left-hand side, and then we can set that expression equal to the right-hand side to find the value of a by solving that equation. So let's integrate e to the x plus e to the minus x with respect to x. The first thing is to remember that e to the x integrates to e to the x, and e to the minus x, you should be very careful. This integrates to minus e to the minus x, because if you just think about this, if you were to differentiate minus e to the minus x, so we differentiate the power, which is just minus 1, and then that becomes the coefficient. So minus 1 times this minus becomes positive. So we'll get positive e to the minus x, which is exactly this term. So that's why the integral of e to the minus x is minus e to the minus x. For now, you can just remember it in this way, but in the next section, we are going to learn the actual method that why this is the case. So yeah, we learn the method because there are some certain functions that we can use a particular method to integrate them like this. But for now, we don't know the method yet. So the limits are ln a and ln 1. Okay, we substitute each of them. First, we have e to the ln a minus e to the minus ln a minus minus e to the power minus ln a, and then we have minus e to the again, this minus that I'm writing is just a minus from here, so minus e to the power of minus ln a, like this. Okay, so at this point, we just need to simplify each bracket. First of all, e to the ln a. So now remember that ln is the inverse function of e, exponential function. So they just cancel each other out. So e to the ln a is just simply equal to a. And then here we have e to the minus ln a. So in this case, also I wanted to correct something. So here we don't have this minus, because also here there is no other. Yeah, here there is a mistake because the power must be e to the power of ln 1, because we only substitute the lower limit here. Okay, now here we have minus e to the power of minus ln a. So from the properties of logs, we can take this minus and raise this a to the power of minus 1, and at this point e to the ln of anything, they just need to cancel each other out. So we'll simply get a to the power of minus 1 with this minus here. So it's going to be a to the minus a to the power of minus 1, which is just a minus 1 over a. And then here, so e to the ln is just going to be basically, again, they cancel each other out, so we'll just get 1. And then here is the same trick, so we can then raise this 1 to the power of minus 1 like this, which doesn't change that, because 1 to the power of minus 1 is just 1 again. But e to the ln, so that's just going to be 1, and then we get minus 1 here. So the second bracket is just 0, and we have a minus 1 over a, and that is equal to 48 over 7. So we solve this equation, a minus 1 over a is equal to 48 over 7. So we can multiply everything by 7 to get 7a, or actually we can take a common denominator and have a, and then a squared minus 1 is equal to 48 over 7, and just cross multiplying, we'll get 7a squared minus 7 is equal to 48a. And now we have a quadratic, so 7a squared minus 48a minus 7 is equal to 0. So solving this quadratic, we'll get two solutions. So one of them is 7 and the other one is minus 1 over 7. But looking at the question, it says a is a positive constant. So therefore, this is the only solution because a is positive.